learning outcomes of these videos. First was the introduction, then what is the need for comparators. You will learn about the basic principles of operations. You will understand the uses of a comparator and what are the essential characteristics of a good comparator, classifications of a comparator, then mechanical and pneumatic comparator, and the difference between comparator and measuring instruments. A comparator is a precision instrument employed to compare the dimension of a given component with a working standard, usually slip gauges. It thus does not measure the actual dimension but indicates how much it differs from the basic dimension. The indicated difference is usually small and hence suitable magnification device is provided to measure the difference with a consistent accuracy. Now we will see how the comparator works with the help of this example. Now consider the component which we have to manufacture in a large quantity as a mass production, of which the having height of 50 mm with a tolerance of plus or minus 0.02 mm means whatever the components which we have to manufacture should have a maximum height of 50.02 mm and minimum height of 49.98 mm. So by using the conventional vernier caliper or a micrometer as an inspection tool to check the dimensions is a time consuming and more skill is required. So instead of using this conventional measuring instrument as an inspection purpose, we can use this dial indicator as a comparator to check the dimensions. So as the basic size is a 50 mm, which is set by using the set of slip gauges. This slip gauge is placed under the plunger of a dial indicator. The pointer of a dial indicator is now set at a 0 position. Tolerance limit which are provided on a dial indicator we have to set according to the tolerance given. Now as the tolerance is given of a plus or minus 0.02 mm means the tolerance pointers should be located toward the left, showing the 0.02 mm as well as toward the right side. Then for inspection process, we have to just put this component under the plunger of a dial indicator and note down the deflection of a plunger should be within a tolerance limit. Then we can say that the component is okay. Thus in this way, the dial indicator can be used as a comparator in mass production. In mass production, identical component parts are produced on a very large scale. To achieve interchangeability, these parts should be produced to close dimensional tolerances. As a result, inspection is often more concerned with the dimensional variation from the standard or a basic dimension of the part. To this extent, inspection becomes a process of comparing manufactured part to the master part designed by the designer. The use of a vernier caliper, micrometer, etc. will not be feasible because of the skill involved and time required to measure the dimension. Use of a comparator requires little or no skill for the operator. eliminates human element for taking measurement and gives quick and highly consistent results. The essential characteristics of a good comparator. The design and construction of the comparator should be robust so that it can withstand the effects of ordinary uses without affecting its measuring accuracy. Recording or a measuring scale should be linear and uniform, and its indication should be clear. The magnification of the comparator should be such that a smallest deviation in size of a component can be easily detected. The indicating system should be such that the readings are obtained in a least possible time. Instrument should be designed that it can be used for wide range of measurements such as linear, angular measurements, outer diameter, inner diameter. So the comparator should be the versatile. Minimum wear of a contact points. The measuring plunger should have a hardened steel contact or a diamond to minimize wear effect. Further, the contact pressure should be low and uniform. The pointer should come rapidly to rest and should be free from oscillation. The system should be free from backlash and unnecessary friction, and it should have a minimum inertia. Means should be provided for lifting the plunger for quick insertion of a work. The table of the instrument should preferably be adjustable in a vertical sense. The indicator should be provided with a maximum compensation for a temperature effect. Suitable means should be provided for preventing damage of the instrument in the event of the plunger moving through a greater distance than that corresponding to the range of its measuring scale. Working principle of a mechanical comparator employs mechanical means for magnifying the small movement of the measuring stylus brought about due the difference between the standard and the actual dimensions being checked. In these comparators, the magnification of the small stylus movement is obtained by means of levers, gear trains, rack and pinion, or a combination. The usual magnification obtained by these comparators ranges from about 250 to 1000. Mechanical comparators are of the following types. One is a dial indicator, and syllabus point of view we have to consider the second as a sigma comparator. The simplest type of a mechanical comparator is a dial indicator. It consists of a base with a rigid column rising from its rear side. An arm is mounted on its column and it carries a dial gauge at its outer end. The arm can be adjusted vertically up and down along the column. An anvil or a work table is mounted on the base, which provides a reference on which the work pieces are placed during the measuring operation. Such a simple comparator is ideal for the checking of components with a tolerance of say plus minus 0.05 millimeters. In its operation, the indicator is set to 0 by use of slip gauges representing the basic size of the part. The part to be checked is then placed below the measuring plunger of the indicator. The linear movement of the plunger is magnified by means of a gear and pinion train into a sizable rotation of the pointer. The variation in the dimension of the part from the basic size is indicated on the dial. Dial indicator is generally used for inspection of a small precision machine part. The dial indicator with a various attachment may be used for a large number of works. With a V-block attachment, it can be used for checking out a roundness of a cylindrical part. Dial indicator mostly used in case of alignment or geometrical test, such as to check the straightness, flatness of machine tables, parallelism, equidistance, and alignment of slide wedge, and access of various moving parts with a reference to some standard planes. True running and alignment of shafts and spindle relative to other areas and surfaces.
Hello everyone, in this video we will see the construction and working of Sigma comparator. Sigma comparator is a simple but ingenious mechanical comparator developed by Sigma Instrument Company, USA. A linear displacement of a plunger is translated into the movement of a pointer over a calibrated scale. The plunger is the sensing element that is in contact with the workpiece. It moves on the slit washer, which provides frictionless linear movement and also arrests the rotation of the plunger about its axis. A knife edge is screwed onto the plunger, which bears upon the face of moving member of cross strip hinge. This unit comprises of fixed and a moving block, connected by thin flexible strips at a right angle to each other. Whenever the plunger moves up or down, the knife edge drives the moving member of cross strip hinge assembly. This deflects an arm which divides into a Y form. The extreme ends of the Y arm are connected to a driving drum by means of phosphor bronze strip. The movement of the Y arm rotates the driving drum and in turn the pointer spindle. This causes the movement of the pointer over a calibrated scale. The magnification of the instrument is obtained in two stages. In first stage, if the effective length of the Y arm is L and the distance from the hinge pivot to the knife edge is X, then the magnification is L by X. The second stage of magnification is obtained with respect to pointer length R and driving drum radius small r. The magnification is given by R by small r. Overall magnification is given by L by X into R by small r. Since we understood the construction, now we will see how it is used to compare or its working. The instrument is initially calibrated to the standard and the 0 is set to this value. Then the test specimen is placed on the measuring table and made to slide below the plunger of the instrument. Any difference in the measured dimension of the specimen will result in either the lowering or rising of the plunger. The lowering or rising of the plunger will make the knife edge to move up or down, and this makes the movable block to deflect, which in turn deflects the Y arm, which turns the drum, and this results in the movement of the pointer, which shows the reading on the calibrated scale.
The use of air as a means of magnification in metrology was originally developed by the Solex company in France for the calibration of carburetor jets. The technique was subsequently developed for other types of measurement. In pneumatic comparators, the deviation of the dimension being measured from the standard is shown by variation in either air pressure or velocity of airflow. The technique offers the advantage of enabling high magnification to be obtained, that is a 30 thousandths to 1 or more, coupled with a good stability and reliability. Such a high order of magnification is possible because no physical contact is made either with the setting gauge or the part being measured, and the internal dimensions may be readily measured not only with respect to tolerance boundaries but also with respect to geometric forms. Further, a single or a more number of dimensions can be inspected simultaneously. A wide variety of measuring heads may be used to suit particular type of work. The two most serious disadvantages are the limited range available and the low speed of response.
Start. Construction of the pneumatic comparator. It consists of a compressor. Compressor is the heart of a pneumatic comparator. Compressor compresses atmospheric air and stores it inside the storage tank. Filter. After the compressor, the filter is present. In this filter, all the dust particles present in the air are separated from the air and clean air passes through this filter. Tank. After the air passes through the filter, the air pipe divides into two paths. Some air goes into the tank and some air goes to the gauging head through the orifice. Orifice. This orifice leads air to the second chamber. Manometer. Second chamber is an outlet to a glass manometer tube. Gauging head. The second chamber is also connected by a flexible tube to a gauging head. This gauging head has two restricting jets that are used to check unevenness or irregularities in the workpiece. Working of pneumatic comparator. In this comparator, compressed air is used as an operating medium. At first, the air is compressed in the air compressor. Then the compressed air from the compressor passes through the air filter. All the dust particles present in the air are separated from the air in the air filter, and only pure air passes through the filter. After passing from the filter, the air pipe is divided into two ways. Some air goes to the tank, and some goes to the restricted jet or orifice. As air enters the water tank, bubbles will be created in the tank, and the rest of the air which passes through the orifice reaches the gauging head through a flexible tube. A controlled amount of air passed through the orifice with the required pressure in it. At this time the manometer shows the initial pressure by which the air passes to the gauging head. The workpiece or the job is reciprocated along the gauging head. This gauge head is generally used to examine the internal diameter of a cylinder, whether it has irregularities or not, in its internal diameter. This gauge head is inserted into the cylinder, and both jets in the gauge head faces towards the internal wall of the cylinder. The internal wall of the cylinder restricts the air coming out of the jet of the gauging head. Based on the gap between the jet and internal wall of the cylinder, back pressure will be created as the internal wall restricts the air coming from the jet. When the back pressure is created, the air which is passing through the gauging head will return back, and it will go inside the manometer tube, and this backflow of air will push down the water inside the manometer. At first, a standard workpiece is taken in which the internal wall is perfectly flat. This standard workpiece is used to calibrate the pneumatic comparator. Using this standard workpiece, the water height as the manometer is adjusted so that it is equal to the height of water in the tank. This standard workpiece is known as a reference workpiece because it is used to get the reference pressure in the manometer. When the gauge head of the pneumatic comparator is placed inside a cylinder which is to be examined, the air hits the internal wall of the cylinder, and if there are any irregularities in the internal wall, the back pressure in the comparator is created and the water inside the manometer is pushed down. Hence, the water level inside the manometer falls, and we get a height difference between the water level of tank and water level of the manometer. This height difference is denoted by delta H. So if the delta H value is high, then we can say that more amount of roughness is there at the position of the cylinder where the gauge head is placed. After the gauge head is placed in different positions inside the cylinder, and delta H is noted for different points so that roughness throughout the cylinder can be measured. If delta H is high for different points inside the workpiece, then this workpiece needs to be rejected. Pneumatic comparator is used when a large number of cylinders or workpiece needs to be tested. That is, when there is the mass production of the workpiece and quality inspection needs to be done. Applications of pneumatic comparator. Cylindricity. The example used in this video is of checking cylindricity. Ovality. To check ovality, we need to rotate the gauging head inside the part. This will give all the variation on the circumference of the part. Similarly, this comparator can be used to check other dimensions like straightness, external diameter, etc.
The difference between the comparator and measuring instrument. Comparator is used to compare the dimension of parts with working standards. It does not measure the actual dimension but indicates how much the size of the part differs from the working standards. Whereas a measuring instrument is used to measure the actual dimension of the part. In comparator, the readings are magnified by suitable arrangement, whereas measuring instruments have no magnification system is provided. Measurements can be done rapidly and accurately, so it is suitable in mass production. Measurement is a time consuming and therefore not suitable for mass production. Comparators can be used to check the dimensions as well as geometric forms. Measuring instruments cannot be used to check geometric forms. In comparator, there are no chance of errors due to incorrect contact pressure or deformation of a workpiece. In measuring instruments, errors are caused due to misalignment or instrument or workpiece, incorrect contact pressure and deformation of an instrument or a workpiece. Accuracy is independent of a correct feel or operator skill in comparator, whereas in measuring instruments, accuracy depends on the correct feel and operator's skill.